This lesson is going to be on recurring decimals and converting them to fractions. So, consider when you have a decimal where you are unable to write them as a fraction. Simply, when we actually have normal decimals that do not recur, for example 0.2, this 2 is in the tenths column, therefore this is 2 tenths. And we can simplify that to be 1/5. Quite straightforward, 0.2, 1/5, simplified as a fraction. Likewise, 0.34. Well, 0.34, there are two numbers after the decimal point. The 4 is in the hundredths column. This is 34 hundredths. Again, two numbers after a decimal point. That also tells us there are going to be two zeros in the denominator. Therefore, we have 100. There was one number after the decimal point was 0.2. There was 1 0. This, of course, simplifies to be 17/50, as both of these numbers, the numerator and the denominator, are both divisible by 2. However, when we are dealing with recurring decimals, it is not so simple. So, for example, 0.18 recurring. I am recurring there with both 1 and 8. This is equal to 0.18181818 ... That pattern continues forever. It's not possible to write it down across the board. In numbers alone, we need the dot notation here on top of the 1 and the 8. If I wish to write this as a decimal, as a fraction, if I try to do it the same way, we would write 18.1818 ... all over 100, and we don't put decimals in fractions. It makes no sense. It's not possible to quite do this. This just simply means 18.18 divided by 100, which is this, recurring. So we have to use a clever trick. And the clever trick is to actually say that we want this number here, I'm going to call it x, and I want to consider what it would be if I times it by 100. I'm going to write 100x here. I will explain why I've chosen 100x in a minute. However, if we take this number and multiply it by 100, all we're going to do is move that decimal point 2 places to the right. 1, 2. And the result will be 18.18181818, carrying on forever in the same way. So this will be 18.18181818. ... I'm going to simplify this side, just remove this from here and write this as x. We now actually can use this very clever trick and subtract one number from the other. Because now I've actually got these decimals here lined up, I can actually just remove them effectively. 8 take away 8 is 0. There's nothing there. 1 take away 1, 0. 8 take away 8, 0. 0, 0, 0, 0, 0. In fact, they would be zeros carried on forever, because after this 8 and this 8, there would be a 1 and a 1. What, however, we have here before the decimal point would be 18. 8 take away 0 is 8. 1 take away nothing is 1. What we have on this side, though, is 100x take away an x. Just like doing 100 take away 1, we would have 99. We have 99 x's. 99x. And so we end up with a simplified little equation from something that was a lot more complicated, which is 99x equals 18. This means 99 times x is 18. We would like to know what 1x is. And quite simply, this is 99 times x. To find out what x is, we do the inverse, we do the opposite thing. So instead of multiplying by 99, we need to divide this side by 99. Divided by 99 gives us just x. We must do the same things to both sides, otherwise the equations don't balance. 18 must be divided by 99 as well. And there you have a fraction. The fraction is 18/99. This is the same as the original number I gave you at the start. the 0.1818181818 going across there, or 0.18 recurring. Both digits are recurring. We can, as before with some of the other fractions, we can simplify this. Both of these numbers are on the 2 times table. Sorry, both are on the 9 times table. So we have 2 and 11. So 0.18 recurring is the same as 2 elevenths. And this process we could do a few times again. So let me just find you another decimal and we can repeat the process. .34. Again, I'm going to put recurring on both the 3 and the 4. This is my value of x. To write this out and work out what this is as a fraction, we write down 100 lots of this, 100x equals, and we write down what we have originally, what one of them is. This would be 0.34343434. Carrying on forever. Times this by 100. Move the decimal point over 2 places. So times by 10 takes it to just after the 3. Times it by 100 takes it to just after the 4. We will have 34.34343434. So all we've done effectively is just, not only have we had to move the decimal point to the right, to another way of looking at it, we have just lifted up all these numbers and shifted them 2 places to the left. So this 34 that you can see here is now this 34 here. And likewise here, here, here. When we do a takeaway, just as before, we will end up with 4 take away 4 is 0, 3 take away 3, 0, 0, 0, 0, 0, 0, 0, all the way across here. In fact, it might be easier just to say all that lot there will disappear when we do our subtraction. So on this side, we have our 99x, again, just like we did in the previous example, and this equals 34. 99 times x. To find out x, we must do the opposite, do the inverse. We divide by 99 here to get x. Divide this by 99 gives us the fraction we're looking for. This, however, does not simplify unlike the previous version, the previous example I gave you. So 34 over 99 is the answer. That equals 34 over 99. I'm going to give you one to do on your own, and I will then guide you through it carefully. So, if x equals 0.25, and those 2 digits are recurring, you're going to have 100 lots of x. You'll need to work out and write down what x is, which is what we have here, but you're going to write the 0.2525252525. I'm going to pause for a second. If you need a chance to pause it yourself, please do. And then I will start up again in a few seconds when you hopefully have unpaused. Okay, let's carry on. Hopefully you have written the 25, 25, 25, 25 across here, dot, dot, dot. Quite important to have that dot, dot, dot. And times it by 100, you would have 25 dot 2, 5, 2, 5, 2, 5, 2, 5, dot, dot, dot. As I did on the previous example, all of these will disappear. When you do a takeaway, you end up with zeros all the way along here after that decimal point. You end up simply with, in this case here, 99x equals 25. And as before, I hope you did this, x equals 25 over 99. And then if you can simplify it, this one does not simplify. 25 is on the 5 times table, the 1 times table, and the 25 times table. So you should only be able to divide by 25 or 5. And here, 99 is not on the 5 times table or the 25 times table. That one is done. However, we may have more complicated ones to do. you may, for example, have x is equal to 0.15, but only the 5 is recurring. So you have x is equal to 0.15. This is 0.15, 5, 5, 5, 5, carrying on forever. In this example, there's only one digit that's recurring. So all we actually need to do is not multiply by 100, but just multiply by 10. We're going to put 10x here instead, and write down what 10x is. I mentioned before that the 5 kind of gets shifted up and over. Well, if you were to multiply by 10, you're going to get 1.555555, going on forever. You end up with those 5s all nice and neatly lined up. There's no need to multiply by any more than 10. When you do your subtraction, you have 9x here, and that equals, well, 5 take away 5 will disappear. All these 5s cancel out when you do subtraction. But here, your 5 take away 1 is 4, and 1 take away 0 is 1. Decimal point must be lined up when you subtract. So 9x equals 1.4. That means x equals 1.4 divided by 9. You should never leave the decimal in a fraction, so we need to get rid of that fraction. One of the simplest things you can do is times both the numerator and the denominator by 10. I multiply by 1, so I get the same thing. The top number and the bottom number, I've done the same thing to them, therefore I end up with the same result. This gives me 14 over 90. I've removed that decimal, I have simplified that. That now is the answer for this, with the slight exception that we can still actually simplify this further to a simpler fraction. Both of these numbers are even, so we divide them both by 2. That is 7 over 45. That's the final answer for this question. Here comes another one. So let's consider x being 0.1253. A much harder question there, a much more complicated decimal. However, we could just perhaps have the final decimal recurring, so put a dot just on the 3. As before, x equals 0.1253. There's just one decimal recurring, so we multiply by the number with just 1 0 on the end. We multiply by 1, 0, x, 10x. Moving that decimal point over gives us 1.25333333. So we have 1.25333333, carrying on across there. All the zeros after this point here will cancel out. Of course, these 3's carry on forever. But all these zeros here cancel out after that point. Those 3's cancel out. That leaves us with 1.253 subtract 0.125. In here, you may need to do some borrowing to make sure you get it correct. 5 becomes a 4, and we put an extra 1 there, because you cannot do 3 take away 5. We need to do 13 take away 5. So 13 take away 5 is 8. 4 take away 2 we can now do is 2. 2 take away 1 is 1. And 1 here. This is our 9x on this side. 10 take away 1, we have 10x take away x is 9x. So x equals 1.128 divided by 9. Putting that number underneath, because it's 9 times x, and we want just 1x. As with the previous example, we have a decimal point in here. We do not want that decimal point, so we have to actually multiply by 1,000. Move that decimal point 3 places over, 3 zeros. It's 3 zeros on 1,000. That is 1128 over 9 1,000. A much more complicated fraction. Hopefully you can recognise both those numbers are even. One ends in an 8, one ends in a 0. They're both on the 2 times table, so we can divide them both by 2. If you have one as complicated as this in your GCSE, it's probably a case that you will have a calculator to finish this off. But that would be 564 over 4,500. Again, that is an even number on the numerator and the denominator. They can both be divided by 2. That will give us a 2 at the end here and a 28 there, 282 over 2,250. It's going to keep going, so both even. 141 over 1125. Hopefully we have finished there. You may need to just double check if they're on the 3 times table. Indeed, that is in fact on the 3 times table here. And we need to check if that is on the 3 times table as well there. Divide this by 3, you end up with 47. And dividing this by 3, we end up with 375. And that is your final answer on that one. So, just to recap, when you have your value of x equaling 0. Any number, 301, for example. In fact, let's give you 303, because that's another one that will end up reducing. So decimal point here, decimal point here. We only have to put the decimal point, the recurring point on top of the last number and the first number that are recurring. This is 0.303303, and that will be x. There are 3 numbers which are recurring. We need to multiply by 1,000. We need 1,000x is 303.303.303. When you do the subtraction here, all these 303s will disappear. You're left with 999x equals 303. X is therefore 303 divided by 999. Both numbers are on the 3 times table. 101 over 333. And that would be the final answer on that one. That there concludes our lesson on recurring decimals being converted to fractions. There are worksheets available to download and buy. Hopefully you'll be doing those and other lessons in the future as well. Take care. Thank you very much for listening to my lesson on recurring decimals. Goodbye.